moving on to 4-5, last section in the chapter. Okay, today we're going to graph solution set of a system of linear inequalities, and then we're going to interpret some solutions, so aka word problem. So this is 4-5. Okay, so 4-4 we looked at just one linear inequality. 4-5 is systems of linear inequalities. So what happens when we have two of these? Okay, so what are the solutions to a system of linear inequalities? Okay, so a system of linear inequalities is made up of two or more linear inequalities. Solutions are ordered pairs that make all of the inequalities true. Okay, so let's look at our first example. Y is greater than x minus 2. Y is less than or equal to negative x plus 1. Okay, we need to look at the solutions of each inequality separately, then find points that are solutions to both inequalities. Okay, so my first one, I'm going to graph in red. Okay, y is greater than x minus 2. Okay, so I start at negative 2. My slope is 1, so I go up 1 over 1. Okay, if I'm getting tired of up 1 over 1, I can also go down 1, left 1. Okay, now we need to decide, okay, is this a solid line or a dashed line? Well, I'm not equal to, so it's going to be a dashed line. Okay, and then shading, it's greater than, so I'm going to shade above. Okay, second equation, y is less than or equal to negative x plus 1. Okay, y-intercept is at 1. Okay, my slope is negative, so I go down 1, right 1, down 1, right 1. Okay, if tired of going down and right, I can go up and left. Up 1, left 1, up 1, left 1. Okay, now I need to decide, is this a solid or a dashed line? Well, we're equal to, so it's going to be a solid line. Okay, now I need to worry about shading. I'm less than, so that means I shade below the line. Okay, so below the line is right here. Okay, so I need to find points that are solutions to both inequalities. Okay, so where can I see both? Well, both would be in the double shaded area, so where it's shaded blue and red. Okay, so right in here is my solution, okay, because it works for both inequalities. Okay, so points in the overlapping region are in both shaded regions. So the solutions are the ordered pairs where the regions overlap. Okay, so my solution is the double shade. Okay, so when you're solving these, look for the double shade. Okay, let's look at this one together. Okay, first one I'm going to do in blue. So y is greater than or equal to negative x plus 2. So negative x plus 2 is right there. And negative x, that's a negative 1, so I go down and right. Okay, or I could go up and left. Okay, it's equal to, so this is going to be a solid line. Okay, shading, I'm greater than, so I shade above. Okay, this one I'm going to do in red. Y is less than negative x minus 2. Okay, so minus 2. Okay, I am negative, so down 1, right 1, down 1, right 1. Or we can go up 1, left 1. Okay, solid or dashed? Well, it's not equal to, so it's going to be a dashed line. Okay, and shading, I'm less than, so I go below. Okay, now look at this one. Where's my double shade? Well, there is no double shade, therefore this one has no solution. Okay, if this was equations, we could say no solution because we notice the slopes are the same. Okay, you can't always say that with inequalities though, because if this one was less than and this one was greater than, I would actually be shaded right here in between the two. Okay, so it all depends on the shading, so make sure you really pay attention to where your shading goes for these kind of problems. Okay, your turn. Pause the video and try letter A, please. Okay, letter A, I'm going to just start with this one. y is less than 2x. Well, I don't have a y-intercept, so that's 0. Okay, remember the slope is in front of the x, so I go up 2, right 1, up 2, right 1. Or I can go down 2, left 1. Okay, solid or dashed line? Well, we're not equal to, so this is going to be a dashed line. Okay, and I'm less than, so I shade below. Okay, the next one. Y is greater than -3. There's no x, so this is just a Hoy line. Okay, so -3 is right here, and it's Hoy, so it's horizontal. Okay, solid or dashed? Not equal to, so it's going to be a dashed line. Okay, and I am greater than, so I shade above the line. Okay, so where's my double shade? Double shade is right here. That's how you do that one. Okay, pause the video and try letter B, please. Okay, letter B. Start with this one. -2x plus 1. Well, here's plus 1. -2, down 2, right 1. Or I can go up 2, left 1. Okay, solid or dashed, it's equal to, so we're going to be a solid line. Okay, and I'm greater than, so I shade above. Okay, this one I'm going to do in red. X plus 2, so plus 2. Slope of 1, so up 1, right 1. Or we can go down 1, left 1. Okay, we're not equal to, so this is going to be a dashed line. Okay, and I'm greater than, so I shade above. Again, looking for that double shade, which is this area right here. Okay, let's do it backwards now. So they're going to give us the graph. We need to come up with the inequality. Okay, so let's start with the red inequality. We need to do the y equals mx plus b, of course. So my y-intercept, 1, 2, 3, so plus 3. Okay, my slope, here's a nice point, here's a nice point. So I go up 2 over 1, so that's a 2x. Okay, first thing now we need to decide, okay, am I shaded above or shaded below? Okay, well notice the yellow shade is for the red line. Okay, so I'm shaded below, so I'm less than. And since it's a dashed line, we leave it as less than. Okay, the next one is the blue, so I'm going to find some nice points. So y, my y-intercept is 4. And it looks like my slope, I just go down 1, left 1. So, or down 1, right 1, excuse me. So my slope is just -1. Okay, now we got to decide, am I greater than or less than? Well, I'm shaded above, so I'm greater than. And since it's a solid line, it's going to be equal to. So there is your solution. Your turn. Pause the video. Try letter A, please. Okay, letter A. I'm going to start the blue line because I got my blue marker up. Okay. Please be very careful here. Notice my scale is going by 2, so be very careful. Okay, so it looks like my y-intercept is at -2. Okay, I need to figure out my slope. Up 1, up 2, over 2. So my slope is just 1. Okay, I'm shaded below the line, so I'm less than. And this is a solid line, so equal to. Okay, the red line. Looks like my y-intercept is a +2. And we find another nice point right here, looks good. So remember, it's going by 2, so 2, 4, 6 over 2. Okay, so this is the same thing as just 3. Shaded above, so I'm greater than, and it's solid, so equal to. Okay, pause the video, try letter B. Okay, so the red line, I'm gonna start nice points. Okay, again, we're now going by 2. So y, let's see, my y-intercept is 0, so I don't even have to put anything there. So I go down 2, 4 over 2. So my slope is -2. Okay, I am shaded above, so I'm greater than. And it's a dashed line, so I leave it. Okay, onto the blue line. My y-intercept to 4 is at -4. Okay, and then my slope, I go up 1 over 2. So my slope is 1/2. Notice I'm shaded below, so I'm less than, and it's a solid line, so equal to. And there's your answers. Okay, so moving on to writing a word problem. Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one. What graph shows the possible numbers of water bottles and pair of socks that she should buy? Well, first thing you need to do with word problems is to define your variables. So let's let X be water bottles and Y be socks. Okay, so the first thing I need to talk about, I forgot part of this. Okay, so it tells us that water bottles cost $2 and socks cost $3. Apologize, I did not have that on my slide beforehand. Okay, so there's that little bit of information. Okay, so first thing we need to know is we have $500. So everything I'm working with is money. Okay, so $500 is the maximum amount of money she can spend. She can't go over 500. So 500 is my max, and my mouth eats the max. And I could spend all 500, so I'm going to be equal to. Okay, $2 for a water bottle would be 2x. $3 for socks would be 3y. Okay. The other information we need to know is at least 200 items. At least, so 200 is my minimum, so I go away from the 200. Okay, and I could be 200. So what kind of items are we buying? Well, we're buying socks and water bottles. Water bottles are X, socks are Y. So that would be my second inequality. Now to graph this, I personally would not do this by hand because those are some nasty numbers. They're huge. So I would use Desmos or something like that to graph. Okay, but there's how you would set that up. We go to the next page, notice it does give us the graph. Okay. So we need to determine if Malia can buy 75 water bottles and 100 pairs of socks. So let's see if that point is anywhere in the shaded region. Okay, 75 water bottles is X, so I'm looking for the point 75, 100. Okay, so 75 would be right in here, 100 would be right in here. Is that going to work? No. She cannot buy 75 water bottles and 100 pairs of socks because that point is not in the double shaded region. Okay. And that's how you do that. So that's how you do linear inequalities. Okay, big thing to remember, if I'm less than, I shade below. If I'm greater than, I shade above. Okay, if it's not equal to, it's a dashed line, and if it is equal to, it's a solid line. Okay, we look for the double shade. So your homework tonight, you are on page 175. You're doing problems 11, 17 through 31 odd. Please make sure you're prepared to ask questions. See you guys later.